Okay, so let's look at some more difficult examples of solving systems by elimination. So this example is a little harder because, for example, the x's and y's aren't lined up, the numbers aren't lined up, and there are fractions in the first equation. So what the first thing I'm going to do is take my first equation and get rid of all my fractions by multiplying both sides of this equation by 18. So 18 times 1/6 is 3, so I get 3x equals, distribute my 18, 18 times 5/18 is 5, so I have 5y, minus 18 times 1/2 is 9. And I'm just going to rewrite my second equation now. So here's my new system. Now I want to make sure all my x's and y's are lined up. So I'll rewrite my system again. So I have 3x. I'm writing my first equation, getting my y on the same side as the x. So subtract the 5y. My second system, I need the x over here as well, but I'll put it before the 2y because in the first equation my x comes before the y. So when I subtract 3x, I get negative 3x plus the 2y equals the constant 3. So there's my new system again. I'm getting closer to the form I need, and in fact now it's very nice because if I add the two equations together, the 3x and the negative 3x drop out, eliminate. So I end up with negative 5y plus 2y is negative 3y, negative 9 plus 3 is negative 6, so y comes out to be a very nice 2. Now I need to take the y value and plug it back into one of the originals to find the x value. I'm going to recommend plugging it into the second equation because it's much easier than the first equation. When I do that, 2 times 2 is 4, so I have 4 equals 3x plus 3. Subtract the 3 and I get 1 equals 3x. Divide both sides by 3 and I get x equals 1/3. So the solution to this system is the ordered pair 1/3, 2. Okay, this system doesn't appear too difficult. The x's, y's, and numbers are lined up properly. We just have to make sure that one of the variables eliminates. So I'm going to eliminate the x's, let's say. So I would want this negative 2 to be a negative 8 so that when I add it to the positive 8 it will drop out. So to make the negative 2 a negative 8, I'll multiply both sides by positive 4 and get a new system. So my new system will be negative 8x plus 4y equals negative 20. That's my first equation after I multiply by 4. My second equation does not change. So here's my new system. Now I can add the two equations together. The x's drop out, giving me 0. The y's also happen to drop out, giving me 0. So I have 0 on the left side, and on the right side I have negative 8. Of course, 0 does not equal negative 8, so this means that the two lines never touch. And if the two lines never touch, they're parallel, of course, and there is no solution to the system because there's no ordered pair where the two lines touch. This example, the x's nor the y's, neither the x's nor the y's will drop out, so let's say I want to make the x's drop out, so I want this to be a 3x, so I'll multiply both sides of this equation by 3, so that when I get my new system, my first equation is 3x plus 6y equals 6, and my second equation does not change. So here's my new system, and now if I add the two equations together, my x's drop out like I wanted, but my y's also drop out. And remember, when you add two opposite things together, you get 0. So I have 0 equals 6 plus negative 6 is also 0. Now when you get this means that the two lines are exactly the same line, so there's an infinite number of solutions, and so the infinite number of solutions are all the ordered pairs on this line. Remember, both equations represent the same line. So we write our solution in set builder notation. So it's a set of every ordered pair such that that ordered pair is on this line. So I'll choose the first equation and say it's on that line. You could use the second equation if you wanted to. But again, this means every ordered pair that's on this line is a solution.